We're going to talk about some of the big pressing issues in generative AI, including whether generative AI has that much more room to run given the constraints on data, compute, and even energy. We are joined today by a very special guest. Swami Sivasubramanian is here. He's the VP of AI and Data at AWS, and we're so lucky to have yet another executive from Amazon Web Services here. Swami, great to see you. Thank you so much for coming on.
Hey, thanks for having me. Really looking forward to our conversation.
Me too. And there was a moment in the podcast that I watched recently and listened to recently where Mark Zuckerberg was talking about the potential constraints on the further building of generative AI systems and the training and the inference of them. And he said, you got to ask Amazon. And actually, here we are. We're with Amazon. So let me set it up for you, and then I'm going to ask you the question. Okay, so he's on this podcast with Dwarkesh Patel, and they're talking about whether we're going to hit a wall with LLMs, because if you think about Llama 3, which Meta just released, which we just talked about, it trained with 10 times more data and 100 times more compute. And Dwarkesh was trying to get Mark to say, well, where's the limit here in terms of you're going to, you're pressing resources on compute, you're pressing resources on data. Are you going to eventually hit an end? And Zuckerberg, of course, says that energy is the real question, right? That it's the fact that if you're going to train these models and run these models, you need very big data centers. And he's talked about the fact that you might even need a gigawatt data center, which is effectively as big as a nuclear power plant. And Dwarkesh, and this is the point here, and then we're going to let you talk. Dwarkesh was like, didn't Amazon do this? And Mark Zuckerberg says, you have to ask them. So I'm curious what you think about the constraints of data when it comes to training large language models, and then maybe you can talk about your efforts since Mark Zuckerberg suggests that we ask you.
All right. First of all, just to give some context, I'll just say AI has the most transformative technology and potential for us. It is the most transformative technology, and the reason we are having this moment and all these conversation is because with the advent of transformer technologies, which is the new neural net architecture, which helps us build these large language models that can learn from huge amount of data, but also be able to actually scale it up. That means you can throw more compute and more data, and then it naturally gets better and better. So that is the reason why now suddenly AI is having its moment. Now, to get to your question, where does it stop? This is what researchers call it as like scaling laws. Saying like, is it actually constantly, are we going to keep throwing more and more compute and more data, or is there no more compute left or no more data left in the world? And this is where few things I suspect is going to happen. One, I don't think we are anywhere close to yet hitting that wall yet. So I do think we are going to actually see a lot of net new innovations when it comes to optimizing how to actually train these models in parallel and get better utilization so that we can continue to actually build these models really well. AWS actually, for instance, we have invested in technologies such as Trainium 2 chips, which actually can deliver up to 4x faster training. And also it is while improving energy efficiency up to 2 times, as an example.
So innovation in compute.
Innovation is compute is only one. Now, the second thing is right now, many of the scaling laws and others are also built upon the assumption of a certain kind of architectures. But if you see already when it comes to how these models are trained, and if you see, there are starting to see new kinds of architectures that are going to change how these models scale in the future. And I suspect that is going to change how these scaling laws are going to be reshaped as well when it comes to that is going to drive net new efficiency gain as well. And
so compute, the architecture of the model.
But
you still didn't answer my question about energy. And so let me just put a fine point on it, right?
Yeah.
what is the biggest data center that you've built to train these models in terms of, I don't know, megawatts or gigawatts? And do you think that there comes a point where energy becomes the biggest constraint on these things? Because that is exactly what Zuckerberg is saying. And this is a guy who has in his back pocket 650,000 NVIDIA H100 GPUs or equivalent. So I think he has an idea of, what the resource constraint might be after you take care of compute.
I think compute and energy are going to be, along with data, are the three dimensions where the scaling constraints are going to be.
But focus on the energy stuff.
Yeah. The energy stuff is a constraint, but that is why AWS, if you see, when we offer compute, we are not just offering server, we are actually offering a cluster that comes with all of it. And this is an area where we have always been investing a lot, not just to actually procure more energy, but also to be more energy efficient as well. So I think there is an inherent, actually, what is going on with the industry, though, is especially in the AI space, is the rate of scaling and demand is so incredibly high. That's why you're starting to see energy consumption needs are also increasing in a big way. And we are actually innovating in a big way, not just in building our data centers and capacity and doing more on this front. And we have made lots of announcements, even including today on some of the new regions we are expanding and so forth, including in India and whatnot. But the other aspect that is equally important is also how do you actually make this energy sustainable? And that continues to be a big priority for us. And
right. No, everybody agrees that making it sustainable is important. But I want to get back to this constraint here. Is there, I mean, it seems like what you're also pointing at here is there is legitimacy in this idea that the industry is sort of coming up against an energy constraint.
There is actually always going to be, we are going to be compute and energy constraint when it comes to this. But this is where I do think that constraint also is contingent on that certain things around how these models are architected and so forth. That is where I'm saying. So it is currently always going to be true. And this is where cloud is actually making it better. That is the nuance I'm actually talking about. And then net new architectures are going to be better. Net new chip designs are also going to make it better. So
yes. And so we should talk a little bit about the way that LLMs are going to be re-architected. So effectively, for the past little while, there's been this, I guess, ever since LLMs became sort of this common thing that everybody started to know about, there was this idea that you just throw compute at them and you throw data at them and they get better. And that's worked for a while. But we have started, energy, I think we agree, is going to be an important issue here. But now going back to these two legacy problems of data and compute, and you think about the way that these models have grown. Just the Llama example, for instance, 10 times more data, 100 times more compute. I mean, they had clusters of, I think, 32,000 or 24,000 something, some crazy number of NVIDIA chips put together. So they and that's from some of like the healthiest compute resources in the whole industry. The data, they also started effectively running out. There was a story in the New York Times where internally at Meta, they were saying, if we don't get more data, we're never going to catch up with ChatGPT, and even started to consider buying Simon & Schuster or spending $10 a book to get the data necessary to train. So I guess this is the question for you, because you're in this position here, right? Again, like, it's so cool to speak with someone at AWS because you have all these resources and you know how the data center works. This is your bread and butter. So before we get into the new architecture, just quickly, is the traditional way of training these LLMs, is that going to hit a wall? Because, it seems like there's fairly little data left to use, and the compute might be kind of running out also. So is it sort of like not a nice to have, but a must have that new architectures are necessary?
I actually think new architectures are absolutely necessary in the future, and there are already hybrid architectures evolving. In terms of state space models to actually connectors, hybrid models between state space to transformers and so forth. But also actually how we are training some of these large language models with even the current data. How do they get reinforced and all those things? There is still a lot of room left when it comes to how these models are getting trained. And you already are seeing actually even Meta, for instance, published a book. It is all about actually high quality data than lots of data, and then being able to cherry pick and do the right cleansing and so forth is number one. And then the second thing is also, it is not about bigger and bigger model when you look at actually what enterprises want, because your view is purely on just model providers who are trying to build model. But take an enterprise who wants to use these models to actually build a chatbot agent, or being able to, or mortgage provider like Rocket Mortgage and so forth, that they want to actually test it in production. It's not about actually picking the most capable model, but in terms of model size or so forth. But they want to be able to take a model and customize it with their data using different techniques, and then being able to get business outcome. So for them, it is not about the most capable model, but it is the most flexible model that actually achieves the trade-off between their cost, accuracy, and latency needs, and then picking that. So,
Right.
and this is where I do think our service like Amazon Bedrock, which actually helps with not just actually always saying the answer is always the biggest model, but instead making it super easy to pick from a variety of state-of-the-art models. It can be like Anthropic or Amazon's or AI21, Cohere, Meta, Mistral, or any of them, but then making it super easy to evaluate for their use case and then build actually an retrieval augmented generation with the right set of guardrails is going to be a big deal. And that's why we are already seeing like tens of thousands of customers actually leveraging
Right.
Bedrock. And the key thing, and this is where it's super easy for us to get always enamored about what is the most capable model. But to put these LLMs to work to solve real world problems, you got to actually take some of these models and then customize it. And the end result is not the biggest model. It is actually a much more customized, smaller model or a digital model to solve specific business problems. And that's what is important.
Well, I sort of disagree with you on that. I mean, I agree with you that the application is important, but the thing that's most important, of course, is how this stuff continues to evolve and get better, right?
Uh,
You wouldn't
it
be
is both
satisfied just saying, let's stop with what we have now.
No, actually, that is not what I'm saying. I'm actually saying that you're not hitting a wall from a customer perspective who are
Hmm.
actually building or innovating with LLMs because there is not enough data. I'm pointing out that even with these LLMs, if I'm actually millions of developers who are trying to build amazing applications, what is important is taking these LLMs and being
Yes.
able to customize it. And that is the point. And still, there is so much innovation and value left to be done there. So that is the point I'm making. And because those set of data is not accessible to any of the model providers and so forth, and there is still a lot of actually innovation that is net new possible because those are actually in secure environments that are not accessible because most of these models are trained on public data or publicly available or that can be
But
procured.
you're not gonna get like a step change if you start changing with trading with Rocket Mortgage data. You might just get a better application for Rocket
That
Mortgage. You're
is,
not gonna advance the field of AI by getting mortgage data in there.
I
I'm not saying
agree.
it's not
And
important.
yeah,
You go ahead.
yeah. But each of these enterprises, each of these startups are actually going to see a step change for their application.
That I agree
Uh,
with.
So
Yes.
that is and all I'm pointing out is that is going to be an equally important element that should not be overlooked. If you imagine every enterprise suddenly got 10x better when it comes to handling customer claims, or actually our developer is 5x more productive, or so forth. That is equally important. And I also think as AI field actually continues to get more and more better and better when it comes to actually training these models, or even changing the architectures to actually be more efficient in terms of how they are actually learning from these data and so forth, how we are reinforcing. You're also constantly going to rewire ourselves. So just look back 6 years ago, even before transformers came about. We thought actually deep learning was actually order of magnitude better than how traditionally machine learning was done. And then we found a new kind of scaling architecture with transformers. And I have no doubt that we are going to actually start seeing similar such things soon as well.
Now, going back to the way that these models evolve, can you talk a little bit about how we have actual, like, the smaller models perform better than the last generation of bigger models? Is it just like the training is different? You talked a little bit about cleaning the data that goes in there. I'm curious what would be involved in that. But how are these smaller models performing better than the bigger models?
There are a few. I mean, the notion of what is small and what is large, we always tend to, debate
Relatively.
it because it's relative, because our definition of small and large keeps changing. But equally important is there are multiple ingredients on what makes a great model. One is actually around how much compute it is we have thrown, but also how much data that we are actually used to train these models, and how do they get reinforced so that the model knows actually it is delivering the right actually responses to certain questions or so forth. All these ingredients are right, and then how do you iterate based on some of these feedback as well. These are some of the ingredients that make into how a model provider trains these models. And if you see, even if someone is actually training a much smaller model when it comes to parameters, but instead they actually are trained on huge number of tokens or so forth with better recipes on reinforcing, there is a case to be made that they are able to actually get higher quality results. The second, if you see interesting research coming out of Stanford or others, is also when it comes to novel architectures that they are talking about, that they expect to see also equally compelling models that are actually going to learn faster, while actually with the same amount of data as well, with potentially even 10x cheaper
Really?
at inference time. And so that's why I'm actually very optimistic about the future when it comes to novel model architectures, which has the potential to disrupt the space in a way. And that's why I keep saying no one model will rule the world in the future.
Let's talk a little bit about your decisions about partnering versus building in-house versus throwing other models out there. Do you have a large team building your own large language models in-house at AWS, and you also have a very big investment in Anthropic. Can you talk through a little bit about what the logic is between kind of going at it in both ways?
Yeah. If you see the history of AWS, we always believed in customer choice. Even when we actually started with, and when I started the database team at that time, the world used to think databases actually it has to speak SQL. And we kind of pioneered the art of, hey, actually customers in fact want different models, different databases for different use cases. And we ended up actually pioneering it, and the rest of the industry, and AWS now has the diverse set of portfolio on the database front, and rest of industry completely pivoted that way. And when internally, now going to the GenAI world and so forth, internally, as we were building a bunch of these GenAI applications, and we saw what it takes to put together actually a model, an end-to-end GenAI application. Well, there is a notion of one powerful model that you need heart of doing some of the things. there are a bunch of different machine learning models that you need, such as you need a model to ingest your data, to do like vectorize your data and do retrieval augmented generation. You need a separate re-ranker model. You need actually a separate model for guardrails. You need an API orchestration to do software agent and automation and so forth. And each of these models vary across capabilities, price, and performance. And what we actually wanted was this led to our belief that no single model will be ideal for every use case. In a way, and especially because in this space we are super early, customers are still learning and experimenting with different models, and that's why at Bedrock we actually started the premise that we are going to actually offer not just our first party but also third party large language models and other foundational models as well, like Anthropic and Meta, Mistral, Cohere, and Stability AI 21 and others. And if you see, we 3 months after GA, after we launched Bedrock and made it generally available, we saw many of our customers actually using more than one model because they were still learning. And I'll just give an example of Thomson Reuters. Labs recently said that having the ability to use diverse range of model was like a key driver for them to innovate quickly because the space is evolving so much. And as well, that's why I actually think this is what is important is not just the individual model, but also the ability to customize for various use cases. And that's where we are starting to see these patterns emerging strongly as well.
You happy with the Anthropic partnership?
Anthropic has been a great partner with us, and they are the producers of one of the most popular models in right now. And especially if you see Anthropic, what they have done with Claude 3, I mean, they are amazing innovation when
Pretty
it comes
wild.
to, the reasoning capability, and they have really been a thought leader and also innovation and responsible AI. And so we are very excited about their partnership, and some of their models on Bedrock has been incredibly powerful and popular with our customers as well. And on the other end, Anthropic will also use AWS Trainium and Inferentia chips to build, train, and deploy their future models and as well. And we have been super excited to see also where in terms of the art of possible. And we are already starting to see huge adoption and customers as well through our joint innovation.
Fascinating. I have a couple questions for you based off what you just said. First of all, you talk about Trainium chips, which you said can train a model 4 times faster than the industry standard.
Yeah.
So have you heard of, so I'm curious to hear your perspective on how things are going there. I mean, obviously, like the reason why people like to go with NVIDIA is because the software is something that they like to use. So I'm curious to hear your perspective on how Trainium stacks up there. And then there's also this other new chip that's called, I think it's called Grok. Not like the Elon Musk Grok, but GROQ, that apparently is training these models like unbelievably fast. So would be eager to hear your perspective on the Grok as well.
First on Trainium. Trainium 2 chips are designed with the sole purpose of being able to train these large language models and highly optimized for training use case. And I mentioned Trainium 2 chips. They are actually can deliver up to 4x faster training than the first generation Trainium chips while improving energy efficiency as well. And we also have a separate instance family optimized for running these models, inference as well, called Inferentia. So the EC2 instances that are powered by our Inferentia chips deliver up to 50% better price performance per watt over comparable EC2 as well, and can reduce cost by up to 40% as well. So, and Internally, I mean, when we are training these models, we are seeing great actually performance. And well, we are also, I mean, well, I can share some of our early customer feedback on some of these because Trainium 2 is not generally available yet, but it has been super compelling and super promising as well because the scale at which it can train has been very, very fascinating as well.
Thoughts on Grok? Or you can't comment on that?
Grok, I have not actually looked at it deeper for me to offer much
Okay.
on it as well.
You talked a little bit about reasoning through our conversation, and there was this whole kerfuffle around OpenAI where they developed this Q-star model that apparently had reasoning in it, and we still never got the full story there. So what is going on? Because from my understanding, with reasoning, it's a different skill, different type of teaching than just spitting back information out because it goes through the steps that it has to take in order to come back to you with an answer. So I'd love to hear your perspective on what the cutting edge of reasoning looks like. And it seems like it's already in production in some of the models that we're talking about.
Yeah. I mean, when it comes to reasoning, let's talk about where the state of the art with respect to reasoning, because reasoning means different things to different people. So the ability to actually take a problem which has logical steps and then break it down into a sequence of actions, which is what these models do. As like, here is the plan I propose, and then being able to break down into, let's say, 5 or 10 steps and then get feedback and quickly iterate and then produce and work output. In a domain like software development, these models are starting to get pretty good. I'd say there are benchmarks like in the software domain, something called the SWE bench, and you can already start to see some of these models are getting pretty good score when it comes to being able to given software development tasks. Like, for instance, today, if you take our GenAI assistant Q, it can actually take a task which a developer will say, hey, I had to work on it today or the next couple of days. Something like, hey, change this error condition for this use case with this error condition, and that is the description they put in their Git repository, and then give it to Q. It will actually consume it and then generate a plan and then get feedback from the developer and say the developer is your condition which their code needs to change is not right. Can you actually do it this way? And then it will update the plan and actually generate the difference in code, saying like, here are the changes I'm planning to make. Does this sound okay? And then it can actually get back and all these are possible today. And so I actually think this reasoning capability is going to actually get better and better, being able to generate a plan and then being able to iterate with a fellow expert, a human, and help them assist to get input on the plan and being able to do. And I think it is a compelling capability. If you look at it, I talked about software upgrades being done by Q. The reason that is possible is, again, it's not just reasoning capability of these LLMs. It is also now we can couple reasoning capability with actually compilers and actually reinforce each other. So when we actually ask, so we don't just ask LLM and say, here is JDK 8 and convert to JDK 7. We instead actually say, here is the thing I'm trying to accomplish. And then we actually also leverage compilers and other technologies to actually play off of each other and iterate back and forth. And that is why this Q capability to do things like code transformation is extremely remarkable in a way that it helps Amazon in a big way. So that's why these reasoning capability is not, if we view it as purely like everything is going to be LLM driven, we as industry are going to be very, very not satisfied. That's why it has to be actually more iterative. And where we work with LLMs as one of the ingredient, it is not the answer for everything.
Right. Okay. In terms of where this computing is happening, so obviously a lot of it's happening in the cloud right now, but Apple has WWDC coming up in just a few weeks, and I bet they're going to make this big play of building LLMs and running LLMs on device. There was a story in Mac Rumors today. It said Apple releases open source AI models that run on device. I think they released 8 of them that run. This is what Mac Rumors say. They run on device rather than through cloud servers. It's called Open ELM, Efficient Language Models. What do you think about this push to run on device? And if people do start running them on device, does it how does it impact the cloud business?
First of all, I do expect the model inference to be happening on multiple areas. This is no different from what happened in the deep learning world. Let's just look at even where Alexa, for instance, it runs in a deep learning model on the device.
Right.
And actually it does certain decisions, and then it does what is like a hierarchical inference, where it knows to route certain queries to the cloud, and certain queries can be answered locally. And in fact, Alexa actually has a very powerful model, which is a tiny model for like the Alexa Auto and so forth. So I expect LLMs to evolve in the same way, where there are a lot of decisions, especially if you have a powerful computing device, which many smartphones and others to be having, that you can actually run some of those simple LLM things at the edge, and you will start. But there is still going to be a huge amount of inference where you need more data that is available elsewhere, or more capabilities and so forth. So I expect this hierarchical capability and hierarchical inference to happen in the same way how it played out in the deep learning era as well. This is some of the other reason why I actually don't view it as you put a big model behind an API and then give data and ask questions. The way these generative AI applications are going to be built is actually like series of things chained together. Some of it is model inference, some of it is actually workflows and whatnot. And that's why that pattern is going to be important, and there are going to be different models and different data connectors, and they all are going to be working together to produce a very seamless experience from a consumer perspective.
So if hypothetically a big mobile device manufacturer tells us that on device large language models are the future, we should view that with a bit of context. Is that what you're trying to tell us, Swami?
It would be hard for me to comment anything hypothetical, but what I can say is there are always going to be actually inferences happening in different layers of the stack, and it is going to happen for different, but there are going to be use cases that are very, very good and just happening at the edge, but there are going to be huge amount of use cases and as well happening on the cloud, and both those use cases are always going to exist.
Okay, great. I want to end with a little discussion about open source. Llama 3 is running through Bedrock, I believe, or AWS day one. What is your view on open source compared to these other closed source models? Dangerous, good, helpful, just one of the pack? What's your thoughts?
Well, we are big supporters of actually enabling access to these models, and I mean, companies like Meta and Mistral have been innovating at an incredible clip in some of these spaces, and with the publicly available weights and so forth. So the key thing, and both of them are doing incredibly well, is also doing it in an thoughtful, responsible way to put the appropriate amount of guardrails and as well. So that's why I actually think this responsible innovation, even in open source, is a good trend, and and I expect that to continue, especially with thoughtful innovation from some of these providers. And those are some of the reasons why we partner with them to even actually make these models accessible to all developers as well.
Can you actually build the guardrails into the models, and can't people override them a little bit once they're open?
These models have built-in guardrails, and they also and in areas like Bedrock, we also layer actually guardrails on top of these models as well. So that imagine if you are an enterprise wanting to build a customer service chatbot for insurance, you want it to be only talking about your data and specific to insurance, and not answer questions related to weather or something else.
Right.
And so guardrails, when we think of guardrails, we always think of the extreme scenarios, but for many enterprises, it is about like, hey, I'm actually trying to keep a topic constrained to this so that I can do it in a certain way. And so that's those, and you wanted to preserve actually like private information or sensitive information and various other things. So that's why on top of some of the guardrails of the individual FMs, Bedrock guardrails also is another layer that helps developers and companies actually get those capabilities out of the box as well. And we see up to 84% improvement in further accuracy because of those capability as well.
Cool. All right, let's end with some fun ones. Are you thinking about building a nuclear power plant to power AI training?
I am not thinking about it myself, but I can't speak to my infra team as well.
Do you think $7 trillion is the right amount, a little bit more or a little bit less than we might need for chip companies that are focused on building AI?
I've never done the math myself to know if it is, but I would say it all depends on what time scale you're talking about.
Right. Inflation these days, it could be next year that's relatively cheap. AGI before or after 2030?
I'd say intelligence is a never-ending pursuit. I think AGI is a very heavily overloaded term and widely misunderstood. So that's why I actually don't use that word. I think intelligence is going to be constantly getting better, but it is going to be human-assisted. Intelligence assisting humans is going to be the future, as my guess.
Yeah, and finally, I didn't mean to demean Rocket Mortgage earlier, just to be clear. I think that this stuff is really fascinating when it comes to business, and it seems like it'll be hand in hand. They will provide the capital necessary to advance the state of the art, and then the state of the art will learn from them as it moves the next models forward. Does that sound kind of right to you, or?
I mean, generative AI is, and it's such an infancy space with so much happening in this domain. And there is a lot of, bright minds working on this space. And our goal is to actually enable all the bright minds to be able to interact with it and actually get the best out of these technology. That's why in AWS we are not just enabling model builders to build these models. That's where we spend a lot of time talking about like how do you actually enable them so that they don't hit a wall and so forth. But this technology won't reach its potential, and you won't have that virtuous loop or feedback cycle unless there are enough people able to consume and build remarkable applications using these models. Otherwise, we are building it with no means to do something useful with it. And that is the other mission we are very excited about. And those are some of the reasons why we actually have built things like Bedrock, which is used by tens of thousands of companies already, or with things like Amazon Q and so forth. This virtuous cycle of actually companies and organization getting useful value out of it and being able to leverage these models to do amazing things. It will sound simple as like what Rocket Mortgage was able to do in terms of automation, or what Bridgewater is able to do, or what Pfizer is doing from like scientific and medical content generation to manufacturing process improvement to Dana-Farber Cancer Institute is using Claude and Bedrock to develop a new research solution. The potentials are endless, and that's what is exciting to me in this space as well. And the good news is we are still just getting started, and it's truly day one here.
Spot on. I agree. And I do think, as I spoke with Matt Wood about and speaking with you, it's just clear that Amazon is just in every layer, whether it comes to foundational model, running other companies' foundational models, helping companies build their own technology and advance it in their own ways. Smart way to do business. Thank you for coming on and speaking with me, Swami, and I hope we can do it again soon. Really good to get a chance to chat.
Hey, me too. Hey, thanks again, Alex. So thanks for having me.
You bet. Thank you, everybody, for watching, and we'll see you next time on Big Technology.